Welcome to the online training about migrating to the Intel Quartus Prime Pro Edition software. My name is Steve. While watching the training, use the controls at the bottom and side of the screen to navigate to any point. Feel free to pause the training at any time. When you're done with the training, please use the link provided in the registration email you're sent to provide us feedback on the training and ways in which it can be improved. I'll remind you about that later. This training focuses on the steps involved in migrating an existing Intel Quartus Prime software design to the Pro Edition of the software. To that end, you'll learn about the different migration paths possible between the different Intel Quartus software products. You'll also learn the details involved in successfully migrating a design. The changes required to project assignments, timing constraints, tickle scripts, IP cores, and other parts of your design will be discussed, and explanations for why the changes are required will be presented. Here's the agenda for this training. We'll start with a look at the migration paths that are available to you. Then we'll look at the basic steps involved before looking at the detailed steps for performing a migration. The detailed steps can be organized into 4 general categories: general project assignment adjustments, timing constraint and related scripting, logic lock assignment changes, and IP core and platform designer system regeneration. Starting with version 15.1, the Quartus II software is now known as the Intel Quartus Prime software. There are 3 versions or editions of the Intel Quartus Prime software: Lite, Standard, and Pro. The Lite edition is similar to the Quartus II Web Edition. It can be downloaded and used without a license, but it has limited device support and does not include all the features of the other editions. The Standard Edition is similar to the Quartus II Subscription Edition. It supports all device families up to the Intel Arria 10 and all existing Quartus features and tools, but it requires a software license for use beyond an initial 30-day trial period. The Pro Edition is new with the move to the Intel Quartus Prime software. It includes a number of new features, including a new synthesis engine and enhanced tools for working with Intel's most advanced FPGA devices. Going forward, the Pro Edition only supports Arria 10 and newer devices. Moving an existing design from the other editions of the Intel Quartus software is the focus of this training. For a detailed comparison for all of Intel's FPGA design software, click the link listed in the slide. While there, you can download the software as well. To understand migrating between different versions of the software, it is important to understand the device support in each one. Device support for each Intel Quartus Prime edition is listed here. Note that currently Intel Arria 10 devices are supported in both the Standard and Pro editions. The Pro edition supports Cyclone 10GX, Arria 10, and Stratix 10. Only the Quartus Prime Pro edition includes the Intel Quartus Prime Pro synthesis engine. Based on the device support in each version, we can now look at the possible migration paths. If you are using the Quartus II Web Edition, the device support is identical to the Quartus Prime Lite edition. You can simply open your Web Edition project in the Lite edition. As usual, when opening an older project in a newer version of the Quartus software, you'll need to recompile your project in the Lite edition unless you create and use a version-compatible database. The same holds true for moving from the Quartus II Subscription Edition to the Quartus Prime Standard Edition. Migrating from the Lite Edition to the Standard Edition is identical to migrating from the Quartus II Web Edition to the Subscription Edition. Enable your license in the software and install any required additional device packages if you are moving to a device not supported in the Lite Edition. The main focus of this training is the final possible migration path, moving from the Quartus II Subscription Edition or Quartus Prime Standard Edition to the Quartus Prime Pro Edition. To simplify the naming of the software products, for the remainder of this training, all Quartus software versions other than the Pro Edition will be referred to as other Quartus software products. Migrating an existing Intel Quartus project to the Quartus Prime Pro Edition consists of 3 main steps. First, you'll update project assignments and other related constraints and scripts, such as SDC timing constraints, to work correctly with the Pro Edition. Note that in most cases, you only need to open an existing project in the Pro Edition and recompile it for it to work. However, this first step may be necessary depending on how your project is set up. Step 2 is to regenerate all your IP cores in your design. This includes code generated by Platform Designer. As you'll see, the software makes it easy to do this. Finally, you may need to make adjustments to your RTL code to be compliant with the new synthesis engine. Before moving a project to the Intel Quartus Prime Pro Edition software, it is recommended to make a backup of your project directory and associated files. This is a good design practice in general, but you may want to create an additional backup specifically for the migration. You can do this manually or use the Project Archive or Project Copy features found in every version of the Intel Quartus software. When working with projects in the Quartus Prime Pro Edition software, be sure to keep project files separate from those used with other Quartus software projects. Project files in the Pro Edition cannot be used with other Quartus software projects. You also cannot compile Pro Edition projects in other Quartus software products and vice versa. So, let's take a look at what is required for Step 1, the assignments and script changes that may be required when migrating to the Pro Edition. One of the main differences between assignments in other Intel Quartus software products and the Quartus Prime Pro Edition is how module instances are referenced in the design hierarchy. In other Quartus software products, assignments need to include both the name of the instantiated entity and the entity's instance name as shown in the example. In the Quartus Prime Pro Edition, entity names should no longer be used in assignments. Only the module instance name should be used. The compiler still accepts assignments that reference the entities, but they are ignored and generate warning messages when read in by the tool. As you can see in the example, referencing just the instances also makes assignments easier to read and understand what part of the design is the target of the assignment. So, the action for this change in behavior is to go through your assignments and simply remove the entity names. You can do this directly in the project's QSF file or using the assignment editor. For new assignments, make sure to just use the instance names. Tools in the Intel Quartus Prime Pro Edition software are now tailored around just the instance name. On the left is the Project Navigator from the Quartus II Subscription Edition software. The project hierarchy lists every instantiated entity and the instance name selected for that entity. On the right, in the Quartus Prime Pro Edition, only instance names make up the main hierarchy display of the project. The entities are still listed, but in a separate column. Along with QSF assignments, timing constraints stored in SDC files may require adjustments as well. In Intel Quartus Prime software products other than the Pro Edition, timing constraints support the use of both the entity and instance names as the name of a target, similar to the use in a QSF file. Unlike with the QSF file, there are no issues and no warnings generated by the tool if entity and instance names are used in an SDC file for a Pro Edition project. No action is required. However, if the SDC file or tickle script that includes SDC commands performs some type of custom name processing on elements of a design, there could be an issue. In the Pro Edition, timing netlist names are converted to strings through the use of certain commands do not include entity names. The returned strings must be processed correctly to reflect this. The getRegisters example shown here is an example of a command that returns names from the timing netlist, specifically the names of registers in the design. The timing exception will be applied to any registers named ACC in the counter entity. In this case, there is no issue due to the wildcard characters. As mentioned, the Pro Edition still understands entities and they can be used in SDC commands. Here's an example of SDC name processing that will not work in the Pro Edition. getRegisters is used again, but this time the names of all registers are converted to strings and stored in the variable named allRegStrings. In the for each loop, the regular expression command compares the expression, which includes the counter entity name, with the current value of the loop index keeper. Regular expression would return true if the expression and the string matched. However, in the Pro Edition, the conversion of the register names to strings does not include the entity name, counter. Thus, the regular expression will always fail. Check your scripts and SDC files to make sure that they correctly handle these types of conversions. In general, try to use standard SDC instead of custom name processing. If this is not possible, You can temporarily re-enable the inclusion of entity names and strings using the code shown here. Wrap these commands around your script to switch to the old mode and then switch back. Synthesizing a design creates internal signal nodes that can be referenced by project assignments. The names of these nodes are based off of the RTL design, but random characters are often added to uniquely identify each one. There is no guarantee that these names remain the same through different versions of the Intel Quartus software, and moving to the Quartus Prime Pro Edition, the name changes may be even more significant. If you have any assignments or commands that reference synthesized nodes, verify and adjust the node names as needed. The Quartus Node Finder is a useful tool for locating synthesized nodes and checking to see if their names have changed when synthesizing in the Pro Edition software. In the same vein, make sure to also check the names of any duplicated registers in your design and the clock outputs of any PLLs. These are common locations for name changes in the post-synthesis netlist. The next required assignment changes are needed if you're using Logic Lock to floorplan your design. With Logic Lock, you create physical regions on the chip and assign logic to each region. Logic assigned to a Logic Lock region will always be placed by the fitter in that region. In other Intel Quartus Prime software products besides the Pro Edition, Logic Lock regions can be non-rectangular through the merging of multiple regions. Regions can also be reserved or floating. A reserved region prevents the fitter from placing any logic in the region other than the logic assigned to that region. A floating region is a region without a specific assigned location on the device, allowing the fitter to choose the best location based on design constraints, including resource usage and timing requirements. In the Quartus Prime Pro Edition, Logic Lock regions from the Standard Edition are now replaced with a new syntax for Logic Lock regions in the Pro Edition. An error is generated by the tool if the old style region assignments are found in the Pro Edition project settings. All old Logic Lock region syntax must be removed or replaced with the new Logic Lock region syntax. The new Logic Lock region syntax is similar to the old Logic Lock region syntax. They are created and managed using the same tools, the Chip Planner, Assignment Editor, the Logic Lock regions window, or through a manual editing of the QSF file, so you could use all the same tools to replace old regions with new Logic Lock regions. However, there are a number of key differences. First, a Logic Lock region cannot be set to floating. It must be set to a specific location in the device floorplan. Logic Lock regions gain some new features over the old region style, including control for routing through the region and the use of the reserved option on nested or non-rectangular regions. Here is a detailed comparison between the two types of regions. Logic Lock standard regions gain full support for selectively including or excluding periphery resources. This includes a new core-only option which completely excludes periphery resources from the region. With Logic Lock standard, placing a region inside another region didn't do much since this nesting did not match up with the design hierarchy. Logic Lock standard matches up physically nested regions with levels of logic in the design hierarchy. Logic Lock standard regions have limited support for reserving nested or non-rectangular regions. Also, reserved Logic Lock standard regions cannot cross I/O columns in Intel Arria 10 devices, requiring the region to be split. These limitations are removed in the Pro Edition. If the core-only option is enabled, a reserved Logic Lock region can cross I/O columns without affecting any periphery logic. Another feature is the ability to set a region as a routing region. The routing region must encompass the existing logic placement region. Logic Lock standard regions also do not require additional naming. They take on the name of the logic assigned to them. You can have multiple instances of the same logic in a region, but currently this is only in non-reserved regions. This may change in a future version of the software. Finally, Logic Lock regions do not allow for the exclusion of arbitrary logic from a region. The core-only option can do this for periphery resources, but non-rectangular shapes should be used to exclude other core resources such as RAM and DSP blocks. As mentioned, the same tools are used to create and manage Logic Lock regions. Other than the New button, You can create logic lock regions in the chip planner in the same way as before by simply clicking and dragging to draw the new region. The logic lock regions window looks different. As mentioned, regions now get a name based on the logic assigned to the region. If no logic is assigned yet, the region is named unassigned and does not get written to the QSF file. New Logic Lock Pro Edition regions are set to reserved off by default. The new core-only and routing region columns enable those features as described earlier. Logic Lock assignments in the QSF file are much simpler than the Logic Lock Standard Edition region assignments. A single assignment specifying the logic assigned to the region and the lower left and upper right XY coordinates of the region are all that's required. Logic Lock Standard Edition regions require separate assignments for all this information. In the example shown, you can see that the ABC logic is constrained to a region whose lower left corner is at 10,10 and whose upper right corner is at 20,20. Non-rectangular regions can also be created in a single assignment. Simply add additional sets of 4 numbers representing the coordinates of each additional rectangles to the assignment. Even if the coordinates overlap, the rectangles will be merged into a single region. As mentioned, nested or overlapping logic lock standard regions match up with the design hierarchy. Because of this, overlapping regions restrict the placement of lower-level design instances. These child instances are constrained to the region of their parent. If a region constraint is added to the child, this constrains the placement of the further lower-level instances. In the example shown here, ABC is constrained to the region of the upper right. Without any additional constraints, all logic for ABC and any lower-level logic, its children, will be constrained to just this region. A second region constraint is added for ABCD overlapping the first region. Now, ABCD logic can be placed in the area of the second region outside of the original ABC region. However, since the two regions overlap, any child instances of ABCD are constrained by only ABCD's parent. Thus, logic such as ABCDE would be constrained to the intersecting region. Be aware of this when recreating your floor plan with logic lock regions in the Pro Edition software. It is perfectly legal to place instances of unrelated logic in the same region location. The first example illustrates this. Of course, the region would need to be large enough to contain the logic from both instances. However, if a region is reserved, overlapping regions are not allowed and the tool generates an error. In the second example, the ABC region is now reserved, so the EFG region cannot be placed on top of it. What if, in the previous example, the second region only partially overlapped the reserved region? In this situation, logic for the non-reserved region can be placed, but is constrained to the area outside of the reserved region. In the example shown here, the EFG region has been extended out past the reserved ABC region. Doing this allows for placement of the EFG logic in the area outside the overlap. When migrating to the Pro Edition, Signal Tap files may also require changes to work correctly. Recall that entity names are not used when creating assignments for logic in the Pro Edition. In a Signal Tap file, used to create one or more instances of the Signal Tap Embedded Logic Analyzer, design nodes are tapped for building trigger conditions and for capturing signal levels when the trigger conditions occur. Entity names must be removed from these tapped nodes. To do this, use the Node Finder to quickly find and remove nodes that include entity names. Run Analysis and Elaboration, the first stage of synthesis, to rebuild the node database, and use the Node Finder again to add the nodes back into the file. If you are tapping post-fit nodes for the logic analyzer, these must be replaced as well. The post-fit node naming scheme is different between other Intel Quartus software products and the Pro Edition. Again, use the Node Finder to find and remove the post-fit nodes. Perform a full compilation, running the fitter, to recreate the post-fit netlist. Now, use the Node Finder again to add the desired post-fit nodes back into the STP file. You can also just perform a full compilation in the Intel Quartus Prime GUI or run Quartus_STP, the signal tap command line executable, to remove signal tap assignments that were created in other Quartus software products. There are a few additional assignments that should be adjusted or removed when moving to the Pro Edition. If you have any assignments that are used for the incremental compilation feature, these must be removed. Incremental compilation, the ability to break up a design into design partitions and then choose which partitions get compiled during subsequent compilations, is not supported in the Pro Edition. Remove any assignments used to create design partitions, set the netlist type to be used for subsequent partition compilations, and any netlist preservation settings. The second step in the migration process is to regenerate all IP in the design. When moving to the Intel Quartus Prime Pro Edition, the files for all IP cores and Platform Designer system designs must be regenerated. When you first open a project in the Pro Edition created in another Quartus software product, if there are any IP cores or Platform Designer systems in the design, the top of the project Navigator will indicate that IP upgrades are required. To regenerate the files, you can reopen the IP parameter editor for each IP core and regenerate them individually, or use the Upgrade IP Components dialog box to quickly regenerate all IP. You can access this dialog box from the button that appears in the Project Navigator or from the project menu. Click Perform Automatic Upgrade to regenerate all the IP. The Upgrade IP Components dialog box should also be able to regenerate any Platform Designer system designs in the project. If you encounter any errors during this process, open the system's QSys file in Platform Designer and regenerate the files there. So why is it necessary to regenerate IP when migrating to the Intel Quartus Prime Pro Edition? Besides the usual reasons for regenerating IP when moving to a new version of the software, such as updated and enhanced timing models, the Pro Edition uses a new scheme for IP core management. In other Quartus software products, a proprietary Verilog configuration scheme is used in the top level of all IP cores and Platform Designer system designs. This is used to prevent ambiguous instantiation errors during synthesis that can occur due to instances with identical names or multiple instantiations of the same instance. While this configuration scheme works for synthesis, problems may still arise during simulation, requiring our user to implement their own fixes, including the creation of separate configuration, deleting duplicate design entities, and renaming identically named entities. In the Pro Edition, this proprietary configuration scheme is not used or supported for IP or Platform Designer systems. Instead, all variants of a particular IP core, even if those variants are configured identically, are compiled into the same library location for the entire project. For example, every instance of the Intel Aria 10 PCIe IP core is compiled into a library named Altera_PCIe_A10_HIP_151. This prevents errors because all instances use the same file sets from the same location. This also eliminates issues with simulating the design because both the synthesis and simulation file sets instantiate design entities identically. Finally, the file directory structure for IP cores now matches the compilation library structure, making it easier to understand how IP files and compiled project files are organized. The final step for migrating a design to the Intel Quartus Prime Pro Edition software is to modify your RTL code to be compliant with the new synthesis engine. Most code will not require many, if any, changes to be compliant, but it's still a good idea to go through your code and check to see if adjustments are needed. To learn all about the optional and required code changes when moving to the synthesis engine, see the free online training using the synthesis engine in the Quartus Prime software linked here. This concludes our look at how to migrate to the Intel Quartus Prime Pro Edition software. To learn about the process and differences between the different versions of the Quartus Prime software, see the Synthesis Engine online training linked here. To get more information about the migration process, see the Migrating to Quartus Prime Pro Edition chapter in the Getting Started User Guide, Intel Quartus Prime Pro Edition, linked here. This slide shows a flow diagram of many of the classes that Intel has to offer and the dependencies that those certain classes have. Here are some support resources that are available to you. One last thing. When you registered for this training, A link was sent to you in your confirmation email that links to a short online survey. Please complete the survey to let us know what you think of this training and if you think of ways it can be improved. Again, my name is Steve, and thank you for listening to this course.